Question 17 says A and B are two similar vases. Vase A has height 10 centimeters and vase B has height 15 centimeters. The difference between the volume of the vase A and the volume of vase B is 1,197 centimeter cube. Calculate the volume of vase A. So since we have two similar shapes, we know that in similar shapes, if you're talking about the volume, your height of the first shape divided by the height of the second shape being cubed equals to the volume of the first shape divided by the volume of the second shape. So we can write 10 over 15 whole cube equals to volume A over volume B, which is going to be 1,000 divided by 3,375 equals to volume A over volume B. They've given us the difference between the volume of vase A and volume of vase B. And they want us to calculate the volume of vase A. So first you find the difference of these two volumes that you found through the similar shape formula. The volume B minus volume A is going to be 3,375 minus 1,000, which is equal to 2,375 centimeter cube. So since we're talking about the differences, we know that the actual difference is given as 1,197. And the difference that we found is 2,375. So we want the volume of vase A for this one, the 1,197 one. So we can write x cube over 10 cube. And now since we're sticking to vase A because that's what they want the volume for, I use the height for vase A with this volume difference, so 10 cube. And for the other, we don't know what the height is. So that's why I'm taking it as x cube. Because they only gave us the difference of volume of vase A and volume of vase B. But the difference that we found using the similar shapes formula, that's 2,375. So you make a fraction of that for the differences and you put it equal to the heights for vase A that are given and the one that we're trying to find. So that's going to be 1,197 divided by 2,375 times 10 cube. This is equal to x cube. Now x cube is your volume of vase A. So when you multiply the fraction by 10 cube, what we get is 504. So that's your answer. Question 21 says the diagram shows the prism ABCDEFGHIJK with horizontal base AEFG. ABCD is a cross section of the prism where ABD is a square, BCD is an equilateral triangle, EF equals to 2 times AE, M is the midpoint of GF, so that JM is vertical. Angle MAJ is Y, so let's connect that first. So this angle is Y degrees. Given that tan Y equals to T, find the value of T, giving your answer in the form of root P plus root Q over 17, where P and Q are integers. So they haven't given us any lengths, but they've told us what shapes are in this prism. We have a square, we have an equilateral triangle for the cross section. So if I assume that AE is X, that means GM would be X over 2 because M is the midpoint of GF and GF is the same as AE. Then since it's equilateral, so if I split the equilateral triangle into two equal triangles, what we get is a special right angle triangle. This would be 60, this would be 30. This length would be X over 2 because like we said, GM is X over 2. So this length would also be X over 2 because it's the same thing. So based on the rules of special triangles, if the length for angle 30 is x over 2. Then for the length that is opposite to angle 90 is going to be twice of x over 2, which will be x. And the length opposite to 60 is going to be root 3 x over 2. So these are the lengths. So this was J, this was H, and let's call this O. So JO plus OM is your height of the prism. So JM is going to be JO plus OM, which is root 3 over 2x, and OM is x. So if we combine that, that's going to be x bracket root 3 plus 2 over 2. Now, next thing we need is the length of AM. So if you notice, this is another right angle triangle over here. Let me just draw it separately. We have a right angle at G. This is A and this is M. So MG or GM we said is x over 2. AG is going to be twice of AE because EF is twice of AE. So EF is the same as AG. So that's going to be 2x. So we need to find what AM is. So AM can be found using Pythagoras because the right angle triangle. So AM squared equals to x over 2 squared plus 2x squared, which is x over 4 plus 4x squared. So that adds up to x squared plus 16x squared over 4, which is 17x squared over 4. We square root both sides. So AM is going to be x over 2, and then we have root 17. So we have figured out what AM is, we have figured out what JM is. So now we can use the tan formula to find out the value of T. So tan Y equals to T. Tan Y is going to be JM divided by AM. So that's going to be root 3 plus 2 times x divided by 2 divided by x root 17 over 2. Take the reciprocal of the second fraction and replace the tan y with capital T. Root 3 plus 2 over 2 times x multiplied by 2 over x times root 17. The x gets cancelled out because they're being divided. The 2 also gets cancelled out. So left with root 3 plus 2 over root 17. Now we rationalize the fraction by multiplying the numerator and denominator by the third in the denominator, which is root 17. So that's root 3 times root 17 plus 2 root 17 over root 17 squared. So that is going to give us root 51 plus 2 root 17 over 17. They wanted both the terms in the numerator in third form. So that means we need to get rid of the 2 with 17. So the 2 that's outside, basically it was a 4 on the inside of the third. So we just rewrite it as root of 17 times 4. And that's going to give us root 68. So now this is exactly the same as the format they wanted in the question, which was root p plus root q over 17. And question 22 says, the diagram shows triangle OAB where OA is 8 and OB is 6b. M is the point on OB such that OM is to MB is 1:2. N is the midpoint of AB. P is the point of intersection of ON and AM. Using a vector method, find OP as a simplified expression in terms of A and B. Show your working clearly. So if you have solved enough like past papers so far, you must have realized that the vector question basically has the same pattern. Like what you will have to do is you will have to take two lengths on which a point lies, and that point is what they're asking you to find. In this case, it's OP. So OP is a part of MA as well and ON as well. How? Because P lies on both the lines. So we will use both these lines, create two separate equations, which would be having OP as the subject, and then we will put them equal to each other to find OP in terms of A and B. So if you understand the steps, you can easily use them in any of the vector questions and you will be able to score your marks. So first, let's begin with finding OM. So M is the point on OB such that OM is to MB is 1:2, which means OM is 1/3 of OB, and that's going to be 1/3 of 6B, which is 2B. Then I'm going to find AB because N is the midpoint of AB. So AB is OB minus OA, and that's going to be 6B minus 8A. Since N is the midpoint of AB, so I'm going to find AN, which is half of 6B minus 8A, which gives us 3B minus 4A. So using that, I can find ON, which is going to be OA plus AN, and that's going to be 8A plus 3B minus 4A, which is 4A plus 3B. So that's ON. Let me just highlight these. This is ON. This is AN. This is AB. And this is OM. Okay. Now, if you notice, OP lies on ON, which means OP is some multiple times ON. That is our first assumption. And second thing is that MP is some multiple times MA. These are our two assumptions based on which we will make equations in terms of OP to find the vector. So for OP, we can easily say that it's going to be lambda times ON, and ON is 4A plus 3B. Now for MP, MP is going to be MO plus OP. We have MO as negative 2B. OP is what we're trying to find. So over here, instead of MP, I'm going to write negative 2B plus OP equals to mu times MA. Now, MA is easy to find because we have OA and OM. So that's going to be OA minus OM, which is 8A minus 2B. So you can once again make OP the subject, and we have mu times 8A minus 2B plus 2B. This is our second equation for OP. What we'll do is we'll put these two equations equal to each other to figure out the value of lambda and mu, and then that will further help us in figuring out what the vector OP is. So lambda times 4a plus 3b is equal to mu times 8a minus 2b plus 2b. We're going to compare the a's on each side and the b's on each side. So 4 lambda, put the coefficient of a on the left-hand side equal to the coefficients of a on the right-hand side. So that's 8 mu. Lambda equals to 8 mu divided by 4, which is 2 mu. So that's one thing. Then we do 3 lambda equals to negative 2 mu plus 2. We can replace the lambda with 2 mu. That's 6 mu equals to negative 2 mu plus 2. 6 mu plus 2 mu equals to 2. 8 mu equals to 2 and mu equals to 2 over 8. Which is 1 over 4. So if mu equals to 1 over 4, that means lambda is going to be 2 times 1 over 4, which is 1 over 2. So that means OP is going to be lambda times 4a plus 3b. Replace the lambda with 1 over 2. Multiply the 1 over 2 with both 4a and 3b. So that's going to give us 2a plus 3 over 2b. That's what vector OP is going to equal to in its simplest form. Question 24 says the curve C has equation y equals to ax cubed plus bx squared minus 12x plus 6 where a and b are constants. The point A with coordinates 2 and negative 6 lies on C, and the gradient of the curve at A is 16. Find the y coordinate of the point on the curve where x coordinate is 3. Show clear algebraic working. So first, I'm going to begin with substituting the point 2, negative 6 in the equation. So replace y with negative 6 and x with 2. So you will notice that then the equation would be just in terms of a and b, not a, b, and x. So when we substitute these, what we get is negative 6 equals to 8a plus 4b minus 24 plus 6. We take the negative 24 and positive 6 to the other side, so negative 6 plus 24 minus 6 equals to 8a plus 4b, which is 12 equals to 8a plus 4b. This is our first equation. Then next is said that the gradient of the curve at A is 16. So for the gradient, we differentiate dy by dx. So for the gradient, we find dy by dx. So we differentiate the equation of the curve. So that's going to be 3ax squared. In differentiation, remember, you bring the power down, multiply that with the coefficient, and then subtract 1 from the original power. So I brought the 3 down, so it became 3ax, and subtracted 1 from the power, so the power of 3 became 2. Similarly, for bx squared, the 2 comes down, so it becomes 2b, and then x has a power of 1 because 2 minus 1 is 1. For negative 12x, it's going to be negative 12 because x has a power of 1. So 1 comes down, gets multiplied with 12, which gives us 12 again. And 1 minus 1 is 0. So x to the power of 0 is 1. Hence, there's no x with 12. So since the derivative is always 0 for the constant, we don't write anything for 6. So this is our gradient. They said that the gradient at point A is 16. So 16 equals to 3a, replace x with 2 again, because at point A, x is 2. So that's 16 equals to 12a plus 4b minus 12. 16 plus 12 equals to 12a plus 4b. So that's going to be 28 equals to 12a plus 4b. This is our second equation. Now we're going to solve these two equations simultaneously to find the value of a and b. So let's write this down over here. 12 times 8a plus 4b and 28 equals to 12a plus 4b. I'm going to use elimination method over here because that's going to be easier to solve. I'm going to eliminate variable b because variable b has the same coefficient in both the equations. So to get rid of b, 4 is positive in the first equation and the second equation, which means we need to subtract the two equations. So when you subtract the two equations, 12 minus 28 on the left-hand side. Over here, 8a minus 12a and 4b minus 4b is 0. That's going to give us negative 16 equals to negative 4a. Negative 16 divided by negative 4 equals to a, which is 4. So that's the value of a. And then for b, we just substitute. And for b, we just substitute a back into either of the equations. I'm going to pick the first one. So 12 equals to 8 times 4 plus 4b. 12 equals to 32 plus 4b. 12 minus 32 equals to 4b, which is negative 20. Divide both sides by 4. And negative 5 equals to b. So that's your value of a and b. They want us to find the y coordinate on the point of the curve where x coordinate is 3. So you substitute the value of a and b in the equation and replace x with 3. So y equals to 4 times x cubed plus negative 5 times 3 square minus 12 times 3 plus 6. And that gives us a value of 33 for y. So that's the y coordinate at that point. So question 15 says that they are recorded the distance in kilometers that he cycled each day for 11 days. Here are his results. Find the interquartile range of his results. So in my opinion, this question isn't like one of the hardest ones, but I still wanted to include this in the video because like I've seen most students make silly mistakes in this. Like they don't realize that they have to, rearrange this in ascending order firstly. Then how to figure out what the upper quartile or lower quartile will be in, ungrouped data. Because with group data, the method is different. With ungrouped data, the method is completely different. So that's why I just wanted to include this question. So what you will do is first step is to always rearrange your data set in ascending order, which means starting from the smallest and ending with the largest value. So our smallest value over here is 5. So there are 2 5s. Then there's a 7. Then there's an 8. Then 10, 12, 13, 14, 16, 21, and 23. He recorded the values for 11 days, which means we have an odd number of data set. So the median value will be the 6th value, which will be right in the middle of the data set. So that's basically your 12th value. So median is 12. Now, they want us to find the interquartile range. So for the interquartile range, we need to find the difference of the upper quartile and lower quartile. So for the lower quartile, we found the middle value of this value and this value. So that's 7. And for the upper quartile, we found the middle value of this value and this value, which is 16. So interquartile range would be 16 minus 7, which is 9. So remember, when you have an ungrouped data set, you first rewrite the values in ascending order. Then you will first highlight your median value. So then the values that are before the median values, you find the middle value of that. That is the lower quartile. And then the values after the median value, you find the middle value of that. That is the upper quartile. Question 18 says, prove that when the sum of the squares of any two consecutive odd numbers is divided by 8, the remainder is always 2. Show clear algebraic working. So first, we need to figure out what our consecutive two odd numbers are. We can say that 2n plus 1 squared plus 2n plus 3 squared. 2n plus 1 is our first odd number, and the odd number after that is 2n plus 3. So we're squaring two consecutive odd numbers, and then we're adding it up, and then dividing it by 8. So when we square 2n plus 1, that gives us 4n squared plus 4n plus 1. And 2n plus 3 whole square is 4n squared plus 12n plus 9. And this is divided by 8. So 4n squared plus 4n squared is 8n squared. 4n plus 12n is 16n. And 1 plus 9 is 10. Now if you notice, 8n squared can be divided by 8, which is going to give us n squared. 16n can be divided by 8, which is going to give us 2n. But 10 cannot be divided by 8. So 10 divided by 8 is 1 whole number 2 over 8. So this is our remainder. So that means yes, when we divide the sum of two consecutive odd numbers by 8, we do get a remainder of 2. So this is what you have to show. Question 19 says PTQ is the diameter of a circle. RTS is a chord of the circle, where TQ is equal to 3, ST is equal to 4, and TR is 12 centimeters. Calculate the radius of the circle. So when in a circle we have two chords intersecting each other, they follow this one simple rule, which is that if two chords intersect in a circle, then the products of the lengths of the chord segments are equal. So basically, PT, which is a segment of the chord, times TQ, which is another segment of the chord, equals to RT times TS. This is the rule for chords intersecting in a circle. This is a rule that most people forget very easily, so just write it down somewhere and remember that the product of this segment of the chords is equal for both the chords. So we don't know what PT is. TQ is 3. RT is 12. We don't know what PT is. TQ is 3. RT is 12 and TS is 4. So PT equals to 12 times 4 over 3, which is going to give us 16 centimeters. Now the question said that PTQ is the diameter. So PTQ is going to be 16 plus 3. So PTQ is going to be 16 plus 3, which is 19 centimeter. And radius is going to be half of the diameter, which is 9.5 centimeters. That's your answer. Question 20 says the histogram gives information about the heights, 8 centimeter of some tomato plants. There are 12 tomato plants of which height is between 75 and 85. One of the tomato plants is selected at random. Find an estimate for the probability that this tomato plant has a height greater than 82.5. Another very scoring question which students easily confuse. So they have given us the frequency for the interval of 75 to 85, which is basically this one. We have the frequency for this interval. We know that this is equal to 12 plants. So we can easily find the corresponding frequency density because if you notice, they haven't given us the scale for the y-axis. Frequency density is frequency over class width. For this interval, frequency is 12 and the class width is 5. And the class width is 10 because 85 minus 75 is 10. Class width is the difference between your maximum and minimum value of the interval. So that's 1.2. So this value basically is 1.2. So if this is 1.2, that means this is going to be 0.5 and this is going to be 1. This one is going to be 1.5 and this is going to be 2. Two big boxes equal to 0.5, which means two small squares add up to 0.1. So based on that, this one has a frequency density of 0.6. This one has a frequency density of 0.8. This is 1. And the last one is 0.4. So as you can see, based on one frequency density value, we have been able to figure out the scale of the y-axis. So now that we know what the frequency density is for each of the bars, we can easily figure out the frequency values. So for 55 to 61, frequency is going to be 0.6 times 5 because that's class interval. And that gives us 3. Then for 60 to 70, it's going to be 0.8 times 10, which is 8. Then for 75 to 80, we already know the frequency, which is 12. But for 85 to 90, it's going to be 0.4 times 5. That's equal to 2. So these are the frequencies. Let me write that in different color. So frequency over here is 2, 5, 8, and 3. These are your frequency values. Now, the question is saying, find an estimate for the probability that this tomato plant has a height greater than 82.5. So 82.5 is going to be in the middle of this. So we know this part over here. Let me shade this. This includes 2.5. And this is a 5. So we need the frequency value for this 2.5 in the 80 bar. So for that, what I'm going to do is, we know that we have 10 columns in this entire bar. So 10 columns represent 12 frequency, basically 12 tomato plants. So one column would be 12 over 10. And we need the frequency for 2.5 columns. So for 2.5 columns, we would do 12 over 10 times 2.5, which is going to give us 3. So 3 tomato plants are in this blue shaded part in the 80 bar. So for this, we know there are two plants. So probability is going to be 2 plus 3 over the total number of plants, which are 30. How did we get the 30? We add 3, 8, 5, 12, and 2. So total plants are 3 plus 8 plus 5 plus 12 plus 2, 30. So 3 are the total number of plants over here in the blue bar, and 2 are over here. So 5 over 30, which simplifies to 1 over 6. That is the probability that the tomato plant has a height greater than 82.5 centimeters. Question 24 says a particle P moves along a straight line that passes through the fixed point O. The displacement x meters of P from O at time t seconds where t is greater than equal to 0 is given by x equals to 4t cubed minus 27t plus 8. The direction of motion of P reverses when P is at the point A on the line. The acceleration of P at the instant when P is at A is a meter per second square. Find the value of A. So when it says that the direction of P reverses when P is at the point A, that means point A is your maximum point. It's your turning point. So after it reaches its maximum value, it reverses its motion. So that means the gradient at point A would be 0. dx by dt over here would be 0. Now, they have given us the displacement equation. When you differentiate the displacement, dx by dt, that gives us the velocity. When you differentiate your velocity, that gives us acceleration. So this is something that you must have heard in physics as well. Derivative of the displacement is velocity and derivative of velocity is acceleration. So we first differentiate the displacement equation to find velocity, which is going to be 12t square minus 27. Then after that, I'm going to differentiate this again to find the acceleration. So dv by dt, that's going to be 24t. Now it said that the direction of the motion of P reverses when P is at point A. So what we do is we put the coordinates of point A. So in order to find the coordinates of A, I'm going to first put dx by dt equals to 0, because that's when your motion is reversing. So 0 equals to 12t square minus 27. 27 equals to 12t square. Divide 27 by 12. That gives us 9 over 4. Then we square root both sides to find the value of t, and that's going to give us plus minus 3 over 2, but we're going to accept the positive value because time cannot be negative. Now they're asking us to find the acceleration at point A, so we put t equals to 3 over 2 in dv by dt, which will give us the acceleration. So that's going to be 24 times 3 over 2, which is 12 times 3, and that's 36 meter per second square. That is your answer. Question 25 says the function g is defined as g of x equals to 5 plus 6x minus x squared with domain x is greater than or equal to 3. Express the inverse function g inverse in the form of g inverse where x approaches. Whenever we have a quadratic function and they want us to find the inverse of it, what we have to do is we have to first convert the quadratic function into completing square form. So for completing square form, let's rewrite this descending order. Negative x squared plus 6x plus 5. First, we need to get rid of the negative sign with x squared. So for that, we're going to take -1 common from the entire equation. So it gives us x squared minus 6x minus 5 in the bracket. Now we need to complete the square. So the square that they're asking us to complete is this thing. So a complete square is basically going to look like this: a plus b whole square or a minus b whole square, depending on what the sign is in the middle. For us, it's going to be a minus b whole square. So a minus b whole square, when we expand, gives us a square minus 2ab plus b square. So if we compare a square minus 2ab plus b square with x square minus 6x, we do have our a square, we do have our 2ab, but what we need is our b square. So to get that b square, we need to figure out what the value of b would be. So let's put 2ab equal to 6x. A is x, so 2xb equals to 6x. B would be 6x divided by 2x, and that's going to give us 3, which means we will introduce plus 3 square over here because that's going to be our b square, but we will also do minus 3 square. The reason why I'm also adding minus 3 square over here is because, as I said earlier, we're introducing a new term in the equation. So if we're adding something new which already did not exist, we're supposed to subtract it as well. So if I'm writing plus 3 square, I'm also going to write minus 3 square. It's the same thing that we do in fractions when we're, adding or subtracting fractions with unlike denominators. If we multiply a number in the denominator, we times the numerator by that number as well. So I'm doing the same thing over here. If I'm adding something new, I'm supposed to subtract it as well. So now our complete square would be the x square minus 6x plus 3 square, which can be rewritten as a minus b whole square, which is x minus 3 whole square. And the minus 3 square, which is 9, and minus 5, they come outside the square part because they're not a part of the complete square, they're separate. Complete square was x square minus 6x, which has a 3 square now, and that completed it into x minus 3 whole square. Now, -1 multiplied by x minus 3 whole square minus 9 minus 5 is minus 14. Multiply the negative sign with the bracket, so the negative sign remain outside because we're not expanding the bracket. And -1 times -14 is positive 14. So this is your equation completing square form. Now, we replace the g of x with y. So y equals to -x minus 3 whole square plus 14. We have to make x the subject. So it's going to be y minus 14 equals to -x minus 3 whole square. Then we divide both sides by -1. So we have -y plus 14 equals to x minus 3 whole square. You must know by now that when we're trying to find the inverse of any function, be it a quadratic or a linear equation, we have to make x the subject. And then at the end, we replace x with the inverse function notation and the y value with x. So right now, I'm trying to make x the subject instead of y. So now we will square root both sides to get the square over here. So it's square root plus minus -y plus 14 equals to x minus 3. 3 goes to the other side, so 3 plus minus root of -y plus 14 equals to x. And last step is to replace the notations. So g inverse x equals to 3 plus minus root of -x plus 14. I'm going to take positive one, not both, because if we look at the equation, it says where the domain is greater than equal to 3. So if we take minus over here, then it's going to be 3 minus, so then it's going to be less than. And when you basically change the original function to an inverse function, you swap the domain and range. So what I mean by that is, like, for example, for g of x, your domain was 1 and range was 4, let's say. So for g inverse x, what happens is that your domain is now 4 and range is 1. So as you can see, we swap them. So over here, it said that the domain for the original function was x is supposed to be greater than equal to 3. So now your range is supposed to be greater than equal to 3. Hence, it cannot be 3 minus root of negative x plus 14. 3 plus root of negative x plus 14. That's why only this comes in your answer, not the negative part. Then it says state the domain of G inverse. Now for the domain, since our range is this, domain is what's going to be inside the root. So your root cannot be negative because we cannot take the root of a negative number, which means negative x plus 14 has to be greater than equal to 0. Negative x is greater than equal to negative 14. Divide both sides by negative 1. So x is supposed to be less than equal to 14. That is your domain for the inverse. Question 26 says an arithmetic series has first term A, common difference D, where D is a prime number. The sum of the first n term of the series is Sn, and sum of the first m terms is 39. Sum of the first two m terms is 320. Find the value of D and the value of m. Show clear algebraic working. So if sum of the first m terms is 39, then 39 equals to m over 2 times 2a plus m minus 1 times d. Right now, I've only used the sum of arithmetic series formula, where I've just replaced the values with what we have. We have the sum value, which is 39. We're talking about m number of terms, so n becomes m. A and d remain as it is because we don't know what the first term or the common difference is. So let's simplify this. So 39 times 2, 78 equals to m times 2a plus md minus d. I expanded the bracket. Again, expand the bracket. 2ma plus m square d minus md. This is our first equation. Now we use the sum of first two m terms. That's going to be 320 equals to 2m over 2 brackets 2a plus 2m minus 1 times d. Once again, we can see that a and d are as it is. What we change is the sum value and the n value, which is 2m now. So that's 320 equals to m brackets 2a plus 2md minus d. Again, expand the bracket. That's 2ma plus 2m square d minus md. That's the second equation. Next, what I'm going to do is I'm going to solve these two equations simultaneously to further simplify it. So 78 equals to 2ma plus m square d minus md. I'm going to subtract these two equations to get rid of the md over here. So 320 minus 78, 2ma minus 2ma 0, 2m square d minus m square d, negative md plus md. That also gets cancelled out actually. So 320 minus 78 is 242 equals to m square d. This is what we have. Now, if we go back to the question said that d is a prime number. So let's think of prime numbers which 242 is divisible by. So 242 being an even number is divisible by 2. 242 is also divisible by 11. And I think that is about it. Yeah, it's not divisible by any other prime number, I think. So if I say that D is 2, then 242 divided by 2 equals to m square. So 242 divided by 2 is 121. So we square root both sides and we get m as 11. Okay, that is the first possibility. Let's check if we can put D as 11 and see what we get. So if we do 242 divided by 11, that would give us 22. And we know square root of 22 is not going to give us a whole number. It's going to be a decimal, which means D cannot be 11. And we'll have to stick to D equals to 2. So D equals to 2 and M can be 11 because 121 can be square rooted. And that gives us a whole number. So this is 2 and this is 11. And that's your answer. Question 11 says, Hamari invests 200,000 yen for 3 years in a savings account paying compound interest. The rate of interest is 1.8% for the first year and X% for each of the second year and the third year. The value of the investment at the end of the third year is 209,754 yen. Work out the value of X, give your answer correct to one decimal place. So for the first year, the interest rate is 1.8%. So let's find the compound interest for the first year. So principal amount, which is 200,000 times 1 plus 1.8 over 100 to the power of 1. Your formula basically is compound interest equals to P times 1 plus R over 100 to the power of time. So over here, the compound interest for the first year is going to be 203,600 yen. Now for the second and third year, the interest rate is X%. So this 203,600 yen will be the principal amount now. So 203,600 times 1 plus X over 100 to the power of 2 because the second and third year, so the 2 years. Now this is equal to the amount given over here, which is 209,754. That is the value of the investment at the end of the third year. So 209,754 equals to 203,600 times 1 plus X over 100 to the power of 2. We divide these two by each other. And that equals to 1 plus X over 100 to the power of 2. And then we will square root both sides to get rid of the square on 1 plus X over 100. So that gives us 1.015 equals to 1 plus X over 100. Then we do 1.015 minus 1 equals to X over 100, which is 0.015 equals to X over 100. Cross multiply, that gives us 1.5 equals to X. That's the value of X correct to one decimal place.